Hello. Okay. First of all, welcome. Thank you, ladies and gentlemen, to attend this workshop on cybersecurity. We prepared it as a journey, so we're gonna travel. So please buckle up. I am Hervé Bury. I am IB Industrial CISO, and I'm representing maintenance activity.
And I'm Servan Pigot. I'm the INC BU Industrial CISO, and I represent mostly design activities.
So let's move on. So first of all, I guess you all know what is Framatome or who is Framatome, but some figures just to remind you where we are and what site we are servicing. One interesting figure is the number of sites that are active in the world where we do service activity. We are not only OEM of these plants, some others are, but we can manage some activity on cyber, and we would like to show you some methodology and have discussion on how we deal with different parts of the process. We choose to do a journey because the thing we're going to speak about are lasting all the life cycle of the plant, from the design part to the servicing part, and this will end up with the decommissioning activities. This will be the journey we're going to go through. We have opportunity then to discuss the journey and discuss details in the cafe room next to this area. So please keep your questions with you so that we can answer them in the cafe area. First part of the journey is the architecture and design part, and Servan will be your guide for this part of the journey. And I will take over with the maintenance activity and everything that happens during the operation and maintenance part that can last very long time for a nuclear asset. So I give the floor to Servan that speaks about architecture.
Yes, so we call this part architecture and design, but please consider that the point is to implement a cybersecurity by design approach during the complete life cycle of the system, starting with the design phase. So we will have three main pillars for this part, which are the graded approach, which is very famous in our industry, complemented by risk management and hardening. So you can go. So the graded approach, what it is, what does it come from? So in our industry, for the cybersecurity activities, we have main referentials, which are the IEEA NSS 17, the IEC 62645, and they promote a defense in-depth approach, which comes with governance, with organizational measures, and with technical elements. And related to the technical part, the way to proceed is to have some systematic assignment of security degrees or security levels to systems depending on their criticality to the plant. Once it's done, we can implement technical measures to each of these systems related to their own level. Then this is reinforced by a grouping, separation into some security zones to make things to go together depending on their needs for communication, their needs for separation, their consistency with security needs. And for the most critical systems, and typically those at the center of the diagram, this can be complemented by a risk management approach, risk assessment, so that measures can be tailored very specifically to the needs, and so that the operator, the risk owner, may have a good view of what is the residual risk, how to mitigate that from a technical view, and also from organizational point of view, so that in the end, the operator is able to approve and to manage this residual risk. And this is really at architecture level, from where technical measures will be like cyber surveillance, but also hardening, which I'm going to talk about now. So just to make things clear, because hardening is a term that is widely used in the industry, and we almost all use it. What I call hardening in this presentation is a process to ensure that we reduce to the minimum the surface of vulnerability of a system, of a given component. The point is to make more difficult, more costly, the attack by a malicious exploitation by a malicious actor. The ways to do that, to achieve this objective, are typically to minimize installation of a given component, to reduce services to the minimum, to activate security services, etc., etc. It can be done for individual machines with operating systems, with network components, with many items. And that must be sustainable over the complete life cycle. It's not a one-shot activity like you do at the beginning and then once it's installed, it's okay. The systems will evolve. They will have vulnerabilities because operating systems become vulnerable because we discover things over time. So what we have seen as absolutely necessary is to include this in the life cycle of the design of the system, and then Hervé will talk about that, but on the complete life cycle, even during operation. So the key points that we have retained in our approach is that we need traceability from the collection of the needs to the implementation requirement specification, but also to up to the testing. We need to be able to have some huge scalability on the measures that we are going to implement, since we are going to touch modern equipment, modern computers, but also sometimes something very old, almost not configurable. So we have to have some leverage, some modification possible. Also, we are going to consider a wide amount of computers or items that are very different. It's not one standalone machine. It's a set of systems, sometimes hundreds at a level of one power plant. So we need to be able to provide with the operator with capabilities to reproduce, to redeploy, to understand what we have done, and to do things in a consistent manner over time. And also, since we are now doing that on all projects, all systems, all machines, we need to be able to integrate the recs that we have gotten in one given project to another. We are using the same operating systems, we are encountering the same issues. If we are not able to do some sharing, some pooling of issues we have identified, then we are doomed to just redo the same thing over time. While here we have a huge opportunity to benefit from that and improve overall the security level of each system, each component. And what is important here is that this approach is done once during design, and then it can be repeated over time during modification phases, during upgrades, during what happens to the system. And then you can switch. And yes, this is applicable, as I said, to the complete life cycle. So basically what I said is just at the first part of the life cycle, and we have a collection of needs, risk assessment, our hardening, of course. And then we go up to the testing. How to do that? Of course, for systems which are safety systems, which have some qualification requirements, we will apply standard VNV methods in compliance with standards which are applicable to the industry. This is the very standard path above, on the top. But for some other systems, maybe some components, some computers which are much less critical, there are other ways to do that in order to go faster and be less costly for a given system. So the point is to say that we do not have a single approach for all machines, all systems. We must be a little bit agile, to take a term that is in the wind, and try to adapt to the real need of the system. And then, once we are done with this first design phase, we will enter into the life of the system, the operation and maintenance phase. Hervé will talk about that just after. But the idea is that this concept of having two paths is completely applicable to this activity, which is monitoring vulnerabilities, surveying them, assessing them, and then implementing remediations, identifying what can be done to correct problems. And lastly, so basically this is continuous improvement of security over the life cycle. One key point we have not talked about is the last part on the bottom, which is how to control what is done. So we have the standard life cycle, VNV, V-cycle, but we are around that. We have some organization on the supplier side, on the OEM side, some organization on the operator side, during commissioning, during site activities. We have a system which is first some pure technical design, paper, software elements on an IT infrastructure, and that ends up being an industrial system. So audit, organizational audit, and then technical audit, in particular penetration testing, configuration audit, etc., is very important in order to identify all along this life cycle at appropriate moments if we don't have some vulnerabilities, some problems that we absolutely want to remediate. So this must be, of course, arranged. It's not that we need to audit at every single minute, but we have key points that typically when we are doing VNV, after we have implemented our hardening, it can be very interesting to be in the position of the attacker and say, okay, we have hardened everything, but really, what can happen? And this concludes what I was able to say you about the life cycle, and in particular the design phase, and I leave the ground to Hervé about the operation and maintenance phases.
So now we jump in time. These elements have been installed, well designed, well tested, installed, and now the plant is living. So that's the O&M world. So we go on doing computer security activity in the O&M world. I will go quite fast in that journey, but you will have opportunity to question additional elements of this journey later on in the cafe. So first of all, we're going to discuss that journey with the very beginning of things. And when we are working with the installed base, you would know that inventory and knowing what you need to defend is the first things to do. And they are most probably the more difficult ones to do if the assets are very old or very different from each other because of the architecture elements or because of the history or your legacy in this plant operation. So first of all, one little tip, you have to manage the way to find your most critical assets. IAEA called them SDAs, and this is NSS Nuclear Security Guide 42 telling us that. But to do that, it's quite difficult because it depends where they stay. If they are very deep in the architecture, you may go with your OEMs, you may go with your supply chain to know exactly what you have. If you are higher in the security grades, so at lower risk because closer to your legacy systems, you may want to do automatic research or discovery, but these solutions are not very suitable in an OT environment. You need to stay with that on a very IT-related components. Then the last thing, if these two things are not working because the OEM does not exist anymore, the only way you have is going documentation, okay? And these documentation are so far the good thing and the bad thing because they are treasure, but it's a treasure that is very difficult to exploit, okay? They are very deep, sometimes in a paper format, so very difficult to exploit. Once you have that inventory thing, which is already a big step in the journey, you need to jump in another one, which is checking about vulnerabilities. Vulnerabilities can be massive. If the asset is having a lot of time or is very well known, you can have a lot of vulnerabilities piling up. Defense in depth in the nuclear world is helping you mitigating that risk. And you need to filter out what are the very true vulnerability you need to manage. You need to know what to filter, what to facet, in order to be sure that what you look at is something that is a threat for your equipment. And to do that, you need to see the vulnerability in the kill chain to be able to say, hey, that asset, that vulnerability is something that may generate an additional risk, which is something that can be done now with nowadays tools. And it's something we practice together. We can discuss that later. Once you have done that faceting thing and you know what to defend against, you need to build your plan, okay? This plan, it is a remediation plan, needs to be on top of your outage activity. And that's again another challenge, because you may know that outage cannot be organized so easily in nuclear. and some assets are very difficult to reach because of their exposure, because of the place they are, and you need to consider some very key indicator or key points to be sure that you are treating the vulnerability when you can, the best you can. And this is some examples of KPIs you can look at to be sure that your remediation plan is a feasible one. One of the indicators, for example, is the OT, or let's say the computer security maintenance time versus the outage time. You can discover that even if this activity is not on the critical path of an outage, having to test, having to validate again that piece of equipment in its running context can be very difficult, tedious. So you need to prepare for these. They are not easy to plan because they touch a lot of things and you need to revalidate everything. Once you have decided the one you want, I want everybody to remind themselves that operators are the one having the single last word. They are the one deciding whether they want to do or not a remediation activity. There are other ways with contingents or with temporary measures to manage a vulnerability you have running. And that's an okay situation. It's not like IT where you want to patch each time you see something. Once you have this information managed, then you go to platform testing. And we have chance in nuclear to have a lot of platforms that are mimicking and sometimes exactly identical to the control systems. These platforms, they are very key in your defense because they are the one telling you whether your remediation techniques are working or not. And this will be, for us, a very big advantage compared to the other business. The only other alternative can be virtualizing this platform using CyberRange. This gives you additional level of trust on assets that are less critical, where you want to activate or try to remediate a large amount of fixes, because they help us to augment the level of confidence we may have in a solution. And the last part is maybe the most important one in that journey, because even if you have done this, everything work, field engineering will be the place where you do the quality. Quality is when you apply your mitigation activity on the assets. As you know, outage worlds are a very busy period or very busy moment for an operator. You have plenty of people running around. You have customer people, you have different maintenance people from different companies. They all have a work permit. They all have allowance to be there, but they are sitting around. They are next to you. And this is very key. And in that area, again, methodology is important. You need to be sure you can master integrity and proper traceability of any action you do on your assets. You need to secure the assets during this phase where it is in a temporary situation, in between a configuration A and B. So that's very important. The second thing you need to master is the capacity to secure the secrets is having, IP address, certificates, capacity to authenticate, capacity to communicate, capacity to configure itself. These configuration elements are sensitive information for your customer, for the operator, and this is quite important to be sure that during your field engineering activity, these information are not leaking. Okay, so that's the second advice. And the third one is having proper transfer and, again, testing. It's not because you have done your test in the validation environment that you are not going to run test again once you have applied the remediation activities. This is something we know already. Nothing from these slides in the O&M world is not something you know. Normally it's state of the art. But what will arrive tomorrow with new designs or with new technology will generate additional challenge. And we need to be ready for that. And I will show you some of them. Here they are. So I use the iceberg picture. This iceberg picture, everybody know it. Let's look at these ones. There are some of them you know already. You are doing monitoring work and data analytics based on some of your INC signals. Big data and data analytics are already in your plants. You have to know that is data that is leaking. And this data that would leak needs to be controlled, okay? Cloud computing, again, is already used in some of your design. If you are using cloud computing, the techniques to secure them are actually not the same than the one we have just shown you. And then behind these two ones that are very known comes the latest, the further ones. Because these new designs will want to have additional intel, additional surveillance, you're going to have Internet of Things coming in. And for these, we need to manage the embedded technology. For autonomous routine, you need to manage predictability, auditability for these techniques. For simulation, you need to manage the scenario. And then for system integration, complexity brings additional validation scenario. So again, these elements are new elements that you're going to have in your environment for new design. And we need to prepare our technology and techniques to manage these. These will probably need fast-paced work, or fast-paced validation for some of them, or deep R&D for some others. And we are ready to discuss about that together in the cafe. Thanks a lot. Anything you want to know about us is meeting us at E114.